Hello, this is Jacqueline Lorenz, and today I will be teaching area models for multiplication. This is for course ITL 516, Mathematics Integrated Design for National University. So for this particular skill is necessary for grades 3 through 5. In third grade, we basically introduce multiplying one-digit whole numbers by multiples of 10. By grade 4, we look at multiplying a whole number of up to 4 digits by a one-digit whole number, as well as multiplying two two-digit numbers. And this is where we introduce the concept of area models, so that by grade 5, they can continue using these area models again, but for quotients and in division. So for today's class, we're going to look at how this would be seen in the 4th grade classroom, because this is where, in the standard, the area models are introduced. So what is an area model? It's basically a visual model that is an alternative to the standard multiplication algorithm by specifically using rectangles to help calculate the product of multi-digit factors. In most textbooks, they'd also call this partial products. So why do we need to know this? Because it's not only helping students prepare to understand the multiplication standard algorithm, but it helps with critical thinking and estimation of products. And it can also help students decompose larger numbers to make them specifically compatible in order to multiply more mentally. So what do we need to know to use the area models? Well, we need to be able to know our multiplication facts 1 through 12, being able to multiply with zeros, so that could either be 20, 30, 90, or with 10, 100, or 1,000. We need to understand how area is equal to length times width, and we will see with our rectangular model why this is so. We continue to reinforce addition and the addition algorithm, and also place value. So how do we create the area model? So let's look at a multiplication problem of 13 times 4. As you can see, we have a single-digit factor, which is 4, and we have a two-digit factor, 13, which has a tens and a ones. So as we set up our rectangular model here, it is split into two parts because we have a tens place value and a ones place value in 13, and it's being multiplied by 4. So I'm going to first split the 13 into tens and ones. Well, I know I have one 10 and 3 ones. And then we're going to put our single digit factor on the outside. So now that we set up our area model, we would multiply, ideally, the length times the width. So we would start by multiplying with our tens here. And we know that 10 times 4 is 40, and 3 times 4 is 12. Now, the reason it's called partial products is because 40 and 12 are parts of the whole product, because we are multiplying according to each place value. So since we know that 10 times 4 is 40 and 3 times 4 is 12, we know that 40 plus 12 using the standard algorithm of addition is 52. Therefore, the product is 52. So now we need to check our work. Well, we know that the inverse operation of multiplication is division. So we need to verify if our factors are correct to receive this product. So we go ahead and we use the standard algorithm to divide. So we know, starting in the tens place, 50 could go into 4 at least 10 times, because 10 times 4 is 40. And so we know that 5 minus 4 is 1, 2 minus 0 is 2. So now we have a new dividend, part of the dividend to work here, which is 12. Well, we know that 12 divided by 4 is 3. 3 times 4 is 12. There's no remainder. Therefore, 13 is correct, and we have multiplied our factors correctly. Now, what if there is a triple-digit factor? Let's look at how we would set this up for a multiplication problem such as 138 times 7. So once again, if we look at our place value, we have 100, a 10, and a 1, as well as a single-digit factor. So we're going to put our single-digit factor on the outside, which is 7. And now we're going to split 138 according to their respective place values. We have 100. We have 3 10s, so 3 times 10 is 30. And we have 8 1s. So now that we set up our area model, we are now going to multiply each place value. So we have 100 times 7, which is 700. 30 times 7 is 210. And 8 times 7 is 56. So again, for multiplying the hundreds and the tens, this is why understanding multiplying by zeros is important, because the amount of zeros we have in our factor need to be included in the product. So we have 700 plus 210 plus 56. We have to add these partial products together. I'm going to add 700 plus 210 first, which is 910 plus 56. 910 plus 56 is 966. So once again, we will need to confirm with our algorithm of division. We know that 100 can be split into 7 100 times. That's why a 1 goes in the hundreds place. 1 times 7 is 7, or 100 times 7 is 700. 966 minus 700 is 266. 266 can be split into 7 30 times, hence a 3 going into the tens place. 3 times 7 is 210. Then we once again subtract. 266 minus 210 is 56. Knowing our basic math facts, we know that 56 divided by 7 is 8, because 8 times 7 is 56, and there is no remainder, and therefore we have our correct factors. Our last example we're going to look at here for today is, what if we have two double-digit factors? So we're going to set up a problem such as 14 times 36. Now, both of these numbers have a 1 and a 10 in them. So we have to split them both apart to be able to calculate all the possible partial products. So I'm going to split 14 first, because I know I have 1 10 and 4 1s. Then for 36, I know I have 3 10s, because 3 times 10 is 30, and 6 1s. So in this case, I'm going to have 4 partial products that I will need to put back together. So now we're going to multiply these parts of the product. We know 30 times 10 is 300. 30 times 4 is 120. 6 times 10 is 60. And 6 times 4 is 24. So now we have to add these up all together to create the new product. So we know 120 plus 60 is 180. Then we're going to add 300 plus 180, which is 480. 480 plus 24, according to the standard addition algorithm, is 504. And once again, we will check our work with division. So we understand that 36 can go into 500 at least 10 times. So we have to put that 1 in the tens place, because 10 times 36 is 360. Then we subtract 504 minus 360, which is 144. Then we know that we can divide 144 into 36 at least 4 times, and then we know that 14 times 30, or 4 times 36 is 144, with no remainder. Therefore, 14 is our correct factor, and our factors match up to our dividend. Thank you very much for joining me on my presentation. And here is more information regarding all of the references that I used to complete this presentation. Thank you.